Okay, this is video 7. This is given the area problems. We have an area, angle, and opposite side, and we need to solve. First, we'll solve for the height, then we'll solve for the offset. So we need the actual geometry of that triangle from the given information. And this is video 7. And then we'll get into substitution and subdivision. Let's go to the solution. We have, here we go, same problem. So the first step is we're going to solve for the height. Done that a few times, pretty simple. 1/2 the base times the height, solve for the height. End up with 25.118. All right. And then I want to copy this. And go down to, so here's the solution. Kind of give you the whole shebang, kind of did the red, orange, green, blue, purple, so you can see the steps and where those steps come from. But what I'm going to do, just a screenshot of it if you like. And let's go to the next one down. So I already copied this. I'm going to just solve it so in order. So let's start out with red. First thing we're going to do is draw the circle. It's a 3-point circle, and you know you're going to need to use this information even if you don't have AutoCAD. So then we're going to divide this base, go H up to here, and we're going to join that with now we have the base and an isosceles triangle. So right here we have 45 degrees, and the circle theorem states that if you have a base that doesn't change in a circle, these 3 points are inscribed in the circle. Any 3 points that are inscribed in that circle, it's still going to be 45 degrees. So let me just illustrate that. 45 degrees. Okay, so that's part of the circle theorem that you're going to need to know. And we've done that. The area will change, obviously, but the angle does not. So we're going to combine those two amounts of information to solve for this dimension that we're looking for. Really, ultimately, the first step is this. That's ultimately what we're looking for, because then we'll have the height, we'll have the offset. So let's just put that in as a X for now. True, in the example I said distance from here to here, but we already know that this is going to be 7.147. So that's a given, actually, or somewhat given. And then what we're going to do is, so another circle theorem that you need to know is a perpendicular bisector will intersect the center of the circle. So this line is going along the center of the circle somewhere. So if we did another line, right here, and we did a perpendicular bisector from there, it's going to also intersect the center of the circle, right? Any one that's anywhere. We do a perpendicular bisector, it's going to intersect the circle center. And then this one here, but that's not necessary, just to let you know that any of them is going to intersect the center. So we're going to use this one, and we're going to do also off the center, and now we know that's intersecting the center of the circle. So now we have everything in red that we're going to do. I think I'm going to go to orange now to solve for some of the circles now. So one circle that now we know the distance, we have an angle here. Now this is 22.5, right? and this one is also, right? But we don't know the radius of the circle yet, so we can probably solve that by creating, now that we know this, right, this dimension here, this is midway between that line, so that and this are going to be the same. Right, let's draw this down a little, make it a little more clear. So those are also going to be equal. And now we have what we need for this triangle. All right. So we have 22.5 here also. All right, we know that's 22.5. And we have the base, so we can solve for this x. So let's do that. T tangent of 22.5 equal to 5.74 divided by x. And then we just solve for x there. We get 5.574 divided by tangent 22.5. Enter, we'll get 13. So now we know this is, if this here is in the middle, and this is in the middle, let's just go, let's do, thinking this is going to be equal to this, right? This triangle, but it's not. So we're going to find the next dimension we need is this dimension, right? So it's pretty similar to the last one. That's also a x, call it a x2. Let's go to green. So tangent is equal to x over 5.574. So there we go. So we know that the last one we did to get this one is to divide. So this one's going to be multiply. So we're going to go 5 times equals x. And then we hit that and we'll end up with text. There you go. 2.252. I think I typed something in wrong. 2.309. That did tangent to 22.5. Enter, and we get text. 2.309. So we got that. Now we have this height minus this height, give us this height, right? So minus that, so we end up with 13.4568. 4568 minus at 2.308 or 39. That's actually should be going into blue, huh? No, we'll leave it in green. We got those just two triangles. There's this. Now we have to solve for, I think originally I did, let's go back to red for a second. I solved this with, we know 22.5, we have this, so we have 11.147, 11.47. Is that a coincidence that this and this are the same on any triangle? Probably another circle there, right? And we're looking for the center of this. No, that is the same. It only happens because it's it only happens because it's a 45-degree angle. So let's go to yeah, if that's 45, that's 90, right, from the circle center. And if that's 90, that and that are the same. So let's go to import 418. So we did this. Now we have originally let's go back to the red. We're going to do this, solve for this one, right? We know tangent of 22.5 equal to 11.147, which is this part of the leg. We're looking for this leg now, right? Divided by x. And x goes to the top, 11.417 stays at the top here. I'm going to say divided by tangent. And we'll end up with that 26.912, 911. That's again with the decimal places. So we have that dimension now, and then what we need is this dimension. So the height of base, which is 1/2 2. So h is equal to 180 times 2 divided by 22.2948. That'll give us the height. I don't think that gives us the height at all. 1/2 the base times the height equals 180 times the height. Okay, that should be it. I don't think it is. I did something wrong though. Let's do that again. So 1/2, 180 times 2 divided by 22.2948. Huh. 22.49. Type it out. T 1/2 times 22.2948 equals 280. And then we go h is equal to 280 times 2 divided by 22.92948. And then we get 25.118, which is rounded up, and so that works out. Let's type that in. Put it over here. And then we can solve for this dimension right here, 26.912 minus 25.118. We'll get 1.794. Now we have this dimension. So what we're looking for now is the dimension that's right here, so that we can get this triangle. So let's see. So first we need, if we get this dimension right here, turn it into blue. Let's solve for that blue dimension first. So we have a 26.912 minus 11.147 and then we hit the compute there, we'll get 15.765. Right here we get 15.765. And then we're going to subtract that minus, well, anyways, we have that first, so we know that's the radius, right? So right here, we're going to add that because we know it. And we have this, but what we want is this triangle now, so we can solve for x, right? So we're going to take the radius minus this little dimension there, minus 1.794, and we'll have 13.7971. That's the dimension that we were looking for. I shouldn't have put it in, but that's one we were trying to solve for. So now we have this triangle. Let's go to purple. So we have this is purple, and we know this 15.765 is the free form. That's our radius, right? Now we can solve for this, so we could use the Pythagorean theorem. Let's go 13.971. I'm going to take 15.765 squared minus 13.971 squared we get the square root of both of those. We get 7.3039. That is how you solve for that in real time. And then you would just obviously add this to that, get your offset. That's the answer we were looking for. All right, that's how you solve it. So we go back here again. You know, I didn't follow the color coordinated exactly right. Didn't show all the steps, so I'm going to go back, give you a chance to look at that and print it if you like, and zoom in and figure out all those different triangles that we solved. And that's how you solve for the that offset, so you can actually get this shape given the area and the opposite side with an angle. So that's how that gets solved. And Let's go. I'll see you in the next video. It's going to be getting into these. These were actually something that I wondered about and probably solved a long time ago and then forgot. So I had to kind of figure this stuff out pretty quick to put it in the video, which is interesting because it wasn't on the YouTube. That's why I'm putting it up here now. So we'll see you on video 8.